All right, we want to look at this function, r is a function of theta, and we're going to look at finding the derivative of this using the limiting process. What we want to know is the derivative of r with respect to theta when theta is equal to 1. So what we'll do is we'll find dr d theta using the limit as h goes to 0 of r of theta plus h minus r of theta over h. Now, to make this a little bit neater, as this does take a little bit of effort, we're going to pull out the 1 over h, so we can look at r plus theta as being 5 over 17 minus the quantity theta plus h, all under the square root, minus the quantity of 5 over 17 minus theta, all under the square root. And what we're going to do is we're going to clean up the fractions first. So we'll keep this outside here, and we'll use a common denominator. So this will be 5 times 17 minus theta minus 5 times 17 minus theta minus h. I'll distribute the negative sign through, all over these two things multiplied together. 17 minus theta minus h times 17 minus theta. And so now we've got, really our problem is here. This is where if I take the limit, I'm going to get division by 0. And so what I want to do is I want to kind of liberate this h from here. And we do that by multiplying by the conjugate. So we'll go 5, 17 minus theta under the square root. Probably won't say that as much as the form of the function's kind of ingrained as we're doing things here, all over our denominator. And just for right now, I'm just going to use d for denominator, so I don't have to rewrite this every single time. Right, so over here we'll just say that's d. Save me some writing. And so let's multiply by the number 1. So I'll put a 5 out here. Over d. And so my conjugate is 17 minus theta square root plus 17. I got my plus in the center. Oops. Sorry, that shifted there. That's better. So what did I say? 17 minus theta square root plus 17 minus theta minus h over the conjugate again. This is our version of the number 1 that we're multiplying by. And as I come over here, take the limit as h goes to 0 of 1 over h. And what I want to do is this 5. I'll pull this 5 over here. Let me Again, just to simplify where everything is, because I could factor out a 5 from this numerator, I'm going to put the 5 over here because I don't want to worry it about now. And I have the reverse of the difference of squares, so I'm going to get 17 minus theta minus 17, so this squared, plus theta plus h, all over d times 17 minus theta plus 17 minus theta minus h. And we notice these cancellations, which leaves me an h upstairs, and these h's cancel. So I now have my problem cleared out, which is where I had an h down here. And so I have 5 upstairs, and then downstairs I have this denominator, 17 minus theta minus h, square root, times 17 minus theta, times 17 minus theta plus 17 minus theta minus h, both under the square root. And so now I can come up here. I can take the limit as h goes to 0. So I'm going to have 5 over 17 minus theta square root times 17 minus theta times 2 17 minus theta, whoops, it's squared, so 17 minus theta in the square root, because they're added. And let's just double check ourselves. If this goes to 0, I have these two things times each other. And if this goes to 0, I have 2 of these things. So all said and done, I have 5 over 2, 17 minus theta to the 3 halves. 1 half, 1 half, 1 half. And now I want to evaluate this when theta equals 1. So for dr d theta at theta equals 1, I get 5 times 2, 16 to the 3 halves. So the square root of 16 is 4. 4 squared is 64, or 4 cubed is 64. Now let's, right, 5 times 2 times 4 cubed, or 5 times 2 times 64, or 5 1/28.